Negative 3x minus 2. I would start with 0. I would always write the equation. Y is equal to negative 3 multiplied by 0 minus 2. So y is equal to 0 minus 2. Subtracting is the same as adding the opposite. So that's negative 2 for the output when y is 0. 0, negative 2. X is 0, so I don't go right or left at all. But y is negative 2, so I go down 2. I'm going to rewrite the equation and substitute a value of 1. Y equals negative 3 multiplied by 1 minus 2. So y equals negative 3 minus 2. I'm going to change that to addition. Subtracting is the same as adding the opposite. So y equals negative 5. So when my input is positive 1, my output is negative 5. 1, negative 5, 1 to the right, and down 1, 2, 3, 4, 5. Now I see that I'm going more and more negative. I want to try a negative input for x and see what happens. Let's try x is negative 1. Y equals negative 3x minus 2. Y equals negative 3 multiplied by negative 1 minus 2. Y equals 3 minus 2. And so that's 1. So when x is negative 1, y is 1, positive 1. So 1 to the left and up 1. And I think you can visualize that line before I even attempt to draw it. That is linear. Oh, that's a terrible line. But you can see that a straight line would go through those points. What do I feel like I've forgotten to mention something important? Oh yeah, I know what it was. Now you're checking your work against what I'm showing. You probably didn't choose those same inputs that I chose. Does your line look, well, it's all the more important for me before I ask this to try to make my line look better than it. I can only, let me see, I think I might have a way of doing it. Sometimes I think speed is the key, but then sometimes I think the opposite. But look, if your line looks like mine, whether you chose other points or not, you got it right. Like it's going through quadrants 2, 3, and 4. It's almost hitting the origin, but not quite. It's to the left of the origin. I mean, just compare your line to mine. The chances that we chose the same inputs are pretty remote. Doesn't mean your line is wrong. If your line looks like mine, you got the right line. Okay, how many possible solutions, how many ordered pairs are there for a linear equation? Well, let's just go back and look at the one we just graphed. I know there's at least 3 because I found 3, but how many could I find? I could choose negative 2 for x, negative 3, negative 4, negative 5. There's no limit to the number of inputs I can choose for x, and that will give me an infinite number of outputs. So there are an infinite number of ordered pairs. There are an infinite number of solutions. So if you're using, now back to this, now we're going to connect this idea of inequalities where we learned interval notation. The domain of any linear equation, wait, I better be careful about that. Let me think for a second. The domain certainly of any linear function is negative infinity to infinity. And we know infinity and negative infinity get parentheses. Let's go back and convince ourselves of that. I could pick any input for x all the way to negative infinity. I could pick any input for x all the way to positive infinity. The domain goes from negative infinity to positive infinity. We know that this line is infinite in both directions. It will spread out, it will take up the entire domain from negative infinity to positive infinity. Likewise, I think you can see that it will also take up the entire range of possible values of y. So y will also, or the range will also be negative infinity to positive infinity. The most important point for graphing a line is called the y-intercept right there, where the line crosses the y-axis. There's also a point where the line crosses the x-axis, and that's called the x-intercept. The x-intercept is less important than the y-intercept, but we'll talk about both of them, and you'll see why the y-intercept is more important later. But I think you can see that if you've got a coordinate plane, you necessarily have x and y axes. That's what defines the coordinate plane. That's what defines everything is relative to the origin. And if you draw a line on the coordinate plane, it's going to have to cross the x and y axis somewhere if it has an infinite domain and range like we just saw. If we look at an actual linear equation and its ordered pairs, it won't surprise you that 0, 4, where x is 0 and y is 4, is the y-intercept, is the point where the line intersects the y-axis, because if we're intersecting the y-axis, that's where we're not right or left at all. In other words, if you were going to intersect the y-axis, it would have to cross the y-axis, and any point on the y-axis will have an x-coordinate of 0. The point where the line crosses the x-axis, see if you know the order. Well, it's right. It's written right there. What am I talking about? 2, 0. So 2, 0 is the y-intercept, is the one we just looked at. The x-intercept is 2, 0. It's where the line intersects the x-axis. And any point on the x-axis has a y-coordinate of 0. It's not up or down. And so those we can use the fact that we know one of the values is 0 to solve for those x and y intercepts. And if we knew the x and y intercept, then we could draw a line through those 2 points, couldn't we? Okay, so I'm going to do, let's see, we're going to do the first 2 together, and then you're going to try the next 4 on your own. If I want the x-intercept and the y-intercept, I'm going to do the y-intercept first, because the y-intercept occurs when x equals 0. And it's pretty easy for me to input 0 for x. 5 multiplied by 0 minus 3. So y equals 0 minus 3. If I'm at 0 on a number line and I subtract 3, I end up at negative 3. You can think of this as adding negative 3. So the y-intercept occurs at 0, x is 0, comma, negative 3. It's easy to find the y-intercept. But the reason it's so much easier to find the y-intercept than the x-intercept is this slope-intercept form is written where y is isolated on one side of the equation. But we can find the x-intercept. We know the x-intercept occurs when y equals 0. So I'm going to rewrite the equation y equals 5x minus 3, and when I write it again, instead of writing y, I'm going to write the value for y, which is 0. 0 equals 5x minus 3. Now we just need to solve for x, and we've done a lot of this year. We want to get rid of this constant term. The way you undo subtracting 3 is adding 3 to both sides of the equation, property of equality. And so you get 3 is equal to 5x. Then you want to isolate x. You don't want to know what 5x equals. You want to know what 1x equals. And you undo multiplying by 5 by dividing by 5. That's property of equality and multiplicative inverse, because 1x is x, and 3 divided by 5 is just 3/5. You can just leave it in fraction form. So the x-intercept has an x value of 3/5. And a y value of course, 0. That's what makes it the x-intercept. This is how you find the x and y-intercept. You substitute 0 for x to find the y-intercept. Then you substitute 0 for y to find the x-intercept. Let's do one more together. The y-intercept, we know x will be 0. So let me substitute 0 for x. y is equal to 2/3 multiplied by 0 minus 2. So y equals 0 minus 2. Subtracting is the same as adding the opposite. So y equals negative 2 when x equals 0. The x-intercept will have a y value of 0. So I rewrite the equation. Y equals 2/3 x minus 2. And then I write it again, but I substitute 0 for y. 0 equals 2/3 x minus 2. We're solving for x. We're trying to find our x coordinate. So I get rid of the constant term by adding 2 to both sides of the equation. I get 2 is equal to 2/3 x. Because the constant term is now 0, that's why we did that. I can make 2/3 x 1x if I multiply by the reciprocal, which is 3/2. But I have to do that on both sides of the equation. That's the property of equality. Multiply both sides of the equation by 3/2. If it helps you to see that as 2/1, you can do that. These 2's will cancel. I get 3/1, which is just 3. 3/2 times 2/3 is 6/6, which is 1 whole, which is why we did it, because 1x is x. And so when y is 0, x is positive 3. And I've got my x and y intercept for this equation. Try the next 4 on your own, and then watch the video to see how you did.